Okay, so today we're going to be looking at section 10.4, expected value. Okay, so to get us started here, outcome value, we need to talk about what that is. It's a value that is assigned to each outcome in a sample space. Okay. Here's the law of large numbers. If we observe more and more repetitions of any chance process, the proportion of times that a specific outcome occurs approaches a single value. And what this basically means is, in the real world, when we do experiments and we do problems like that, it's what's called experimental probability. And then you have the other end, which is the theoretical probability. Theoretical is what happens when I do something more and more times. Like if I flip a coin, I'm going to get heads or tails. Okay? If I flip a coin 10 times, that doesn't mean I got 5 times I got heads and 5 times I got a tails. I could get any combination of heads and tails. What the law of large numbers is saying is that if I do this a lot of times, the probability of flipping a heads is going to get closer and closer to a single value, which is going to be 1/2, the theoretical. So that's what this is kind of saying, and we use that because we're going to now look at expected value. Okay? Expected value is what's used in the real world for many, many, many things. And what it does is it gives an idea of what a potential earnings could be in some situations. For example, as we're looking, we have a bunch of examples we're going to look at here, but some of them are carnival games. Okay? Why do they charge so much? Okay? Why? How do they make money if only a few people play? You know, but they're playing, and also another one it would be casinos. You know, they set the machines up in such a way so that it seems like you're winning a lot, but in actuality, the casino is making money every time you play, and the casino's not worried about playing. You know, you winning the big jackpot because they've compensated that because every time somebody plays a machine, they make money from it. And so they're playing the large number game. You're playing an individual game. You may only play, let's say you have a lot of money, you play 100 times. Okay? And, you know, for you, that's a lot. That's a lot of money. But they're playing the game thousands and thousands and thousands of times. So they're playing a much more number of times than you are. And so they don't need to win the big prize or have you lose all your money. You can win a bunch of times, but in the end, they're going to win overall. And that's what expected value is talking about. It is a weighted average for a random experiment each time that it is run. Okay? The sum of the value of each outcome multiplied by the probability of that outcome. So that's what the outcome values are. Okay? And so we're going to look at this, and this is the formula for expected value. These X's right here, subscripts, represent the values of the outcomes of a set of trials. So we're going to take the value that was assigned to each outcome and multiply it by the probability that that outcome is going to occur. When we do that and add up all those possibilities, we get what's called the expected value. And we'll see how this works out here in terms of examples. And so I have an example right here we're going to look at. Pull this over here so you can see it. We're going to look at this one up here at top. This table here shows the data on sales in 1 month for each item on a menu in a restaurant. To estimate the future profits, the owner evaluates the average profit from each meal. So every time he serves stew, he makes 39 cents. So the cost of making the stew and all that kind of stuff, and he profits 39 cents for that bowl of stew or that plate of stew. Okay? What is the average profit that the owner can expect to make from each meal? So overall, what's going on here? So that's what we're talking about. So no matter what meal I'm serving, what can I expect to earn from that meal? This over here is the percentage sold. So this is like your probabilities of each of these meals. So my expected value, starting with the first one, this is the outcome value. This is how much they expect to get from it. So 39 cents times the probability of this outcome is 0.12. And we do that for each of these. So then we'll have 0.41 times 0.08, and then add 62 cents times 46%, and then 68 cents times 34%. Okay, so we work all this out on a calculator, and we will get the number 0.596. So what does this mean? That means however many meals he serves that, that week or that day or whatever, the owner can expect to earn a profit of about 60 cents per meal. That is how expected value works. So he can then price his items in a way that he either raises or lowers this accordingly. Because if he makes too much profit, then the prices are going to be so high that no one wants to buy anything. But he still has to make a profit. Is he going to make enough money with 60 cents per meal to pay all his bills? So you have to make these decisions this way. And that's how this is kind of used in the real world. One example of it. Here is another example. I was talking about the carnival game. So here's our carnival game. We have a spinner over here. And the game is this. You get to pay me $1 and you spin this wheel. Okay? And if you land on the Y, I'll give you $4. If you land on R, I'll give you $1. If you land on B, then you lose, so you don't get anything. And it costs $1 to spin that wheel. Okay? So the question then is, and each time we do this, expected value is based off a point of view. So I can do this from the point of view of the owner of the game, which is what I'm going to do, or I can do it from the perspective of the player in the game. And then you can decide if you want to play or not. So first thing you want to do is you need to find the probability of each outcome. So we have a yellow, a red, and a blue. So what is the probability of getting a yellow? Well, that's 1 out of 8. What's the probability of getting a red? That is 2 out of 8, or 1/4. And what is the probability of getting a blue? And that is 5 1/8. Okay. So now we can talk about the expected value. So remember, expected value is an outcome value times the probability that it will occur. From the owner's point of view, if you land on yellow, then the owner loses money because he has to pay out $4. But how much did he lose, really? Because you gave the owner $1 to spend. So he has your $1 in his hand. And when you win, he has to pay out 4, so he gives you back your $1 and then 3 more. So that means his outcome value is -3. And that happens for the yellow, which is a probability of 1/8. Let's look at the other one. The next one is you spin a red. Again, you give the owner of this game $1. If you spin on the red, he gives you back your $1. So what did it cost the owner? Nothing. It doesn't cost the owner anything if you land on red. He doesn't earn anything, and you get back your $1, and you think that you won. And that happens 2/8 times, or 1/4. The last one is you land on blue. He gives you $1, so you give the owner $1. He has your $1 in his hand. You land on blue. He does not return your $1. He gets to keep it. That means from the owner's point of view, that is a +1 win for him. And that happens 5/8 times. So if you work this all out, this is a -3/8 plus 0 plus 5/8 gives me 2/8 or 1/4. So what does that mean in context of this problem? That means the owner can expect to earn 25 cents per game. So again, he's not playing for the short term. He's not playing for 1 or 2 spins. Okay, he set up his game. He wants people to play 100 times, 1,000 times, or even more. The more times people play, the more money he can make if he's making 25 cents per game. Okay, it's the game. It's the long term he wants to play for, and so you can see that this can rack up pretty quickly if he gets a lot of people to play. So if this number is too great for him, nobody wants to play his game, okay? Because people just seem like they're losing all the time. So he has to set it up in such a way that he actually gets big, people make a lot of money and then they spread the word and stuff like that. And so you can change things in this problem. You can change the payout. You can change probabilities by putting more pieces in here. It depends on what you want to do. And that can change this expected earnings value and get it to a point where the carnival owner will make money, and yet it seems like the people who play win a lot. And so this is the lure of casinos and stuff. Especially the slot machines. It seems like with all the bells and whistles and all the activity going on that people win a lot. When in actuality, the casino is making money every time you spin that wheel in the casinos. So where else would I use something like this? Okay, well, insurance companies use this. Okay, so an insurance company offers 2 policy options. The probability that a car will be damaged in a given year is 2.7%. Which option has the least expected annual cost for the car owner? Okay, again, it just depends on the point of view. We're going to do this from the point of view of the car owner. You want to know which policy to choose, and you can use this idea to figure this out. So we're going to look at Plan A. Plan A has a known cost of $600. This is your known cost. And to this, we want to add the expected value of any additional unknown costs that might come up, like if you have a car accident and things like that. So what is the expected value? What can I expect? The expected value of unknown costs. Okay, so I take the 600 and add this. Well, what do I know? Well, that is the probability that you might get in a car accident, but that is your deductible. And in case you don't know what a deductible is, it's what you have to pay up front before any repairs are done on your car. So you have a 0 deductible. It means you don't have to pay anything. And the chances that you might need to have your car fixed from an accident or whatever is that right there. And so when you multiply things together and add this up, you get $600. So Plan A is a $600 policy for you. What about Plan B? So Plan B, the known cost is $500. But now I have a $1,000 deductible. Okay, so if I get in a car accident, I have to pay $1,000 up front. Okay, and then the insurance will pay anything beyond that amount to fix my car. Well, what are the chances of getting in a car accident? Well, 0.027. And if I multiply everything out and add these things up, I'm going to get a total over here of $527. And so the question then you ask is this. Well, the question was, which one has the least expected annual cost for the car owner? Well, clearly it's Plan B. Okay. So the difference here is that you got to decide. Do you pay the extra money every year for a small chance of being in a car accident and you don't have to pay anything, or do this every time and then pay the $1,000 if you get into a car accident? So you're saving this money every year, or you don't. It's up to you. And that's the kind of decision people have to make when they do buy insurance policies and stuff. What do I insure? What's it going to cost me? What's the return going to be if I get into this accident? Is it worth it to me? That kind of decisions have to be made. But that's one of the ways you can make that decision. So here's another example that can be used in situations. So Mercedes is planning a party for 10 people. She knows from experience that about 20% of those invited will not show up. If she invites 12 people, what is the probability that more than 10 people will show up? And should she invite 12 people or some other amount? And explain. Okay? So what's going on here is kind of using the concept of the binomial probability situation. Okay? You got material for 10 people, not 12. Okay? But she has people who don't show up. You know, doesn't mean they're not going to show up. If you invite 12 people, all 12 can't show up. So what she wants to know is what's the chances that that's going to happen. Okay? So this one uses a binomial probability, which was, if you remember the formulas, was NCR times the probability of the event happening to R, and then the complement and N minus R. So in this situation, the two things that can happen is I can have 11 people show up, or I can have 12 people show up. So you got to do one for each of those. So 12 people invited, 11 show up. The chances of showing up is 80%, because 20% don't show up. So 80%. And then the don't show up are 20%. And there's only one of those. That's for the chances of 11 people showing up. And then the other one is, what if I have 12 people show up if I invite 12 people? So then this will be 0.8 to the 12 and 0.2 to the 0. And you work this out on the calculator, and you're going to get 0.2749, or a 27.49% chance that somebody is going to show up beyond 10 people. So from that information, you now have to make the decision. Should she invite 12 people or some other number? Okay, you got to make that decision. If you invite 12 people, there's a 27% chance that you're going to have more than 10 people. Is that really a problem for you? Though this is the decisions you would have to make based off of what you're trying to figure out. And so you want to make an argument now based off of this information. Well, yes, she should, or no, she shouldn't. And that's something you would have to make that decision for. Okay. The last one down here we're going to look at is another situation here. So suppose 0.5% of the people who file tax returns with an annual income between this and this are audited. If 5 people in that income range for whom these guys prepare taxes, 2 were audited. Okay, so that's the information we're starting with. If 5 people in this bracket are selected at random from all the people who file the federal tax returns, what is the probability that at least 2 of those people will be audited? And then the secondary question is, would you, based off this information, would you recommend these tax guys to your friends do their taxes? So let's start this off. We need to find out the probability that at least 2 are audited. At least 2. That means it can be 2, 3, 4, 5, 6, a gazillion, a bunch of them. Okay, so it's too difficult to go directly and do each one. So that's what we had to do here. See, we had 2 up here, so we did 11, then we did 12. Okay, if she was going to invite 15 people, we would have to do 11, 12, 13, 14, and 15. Okay, that's too many to do in this situation, 2 and higher. Okay, so what we have to do is we have to use the complement for this. So if I want at least 2 are audited, then I can do 1 minus the probability of 0 or 1 are audited. See, that's a smaller number to deal with. So what is that probability? What is the probability of 0 or 1 audited? Well, if it's 0, it's again the binomial thing. So it'd be 5, choose 0 people. The chances of being audited are 0.005. Change that to a decimal. And that happens 0 times. And the chances of not being audited is 1 minus that. And that happens 5 times. And then 5, choose 1, 0.005 to the 1, 1 minus 0.005 to the 4. So we can use our calculator to figure this number out. And that number is 0.9997529. So plugging this number into this right here. So the probability that at least 2 are audited is 1 minus this. Which is approximately 0.00025 and or 0.025%. So then the question is, would you recommend these tax preparers to your friends? Well, we have to ask that question here, okay? So if you look up here, 5 people that these guys did in this tax bracket, 2 of them were audited. Well, 2 out of 5, that's 40%. Whereas any random 2 people being audited in that tax bracket is 0.025%. I'm pretty sure that these guys aren't very good if that many people are getting audited from those people, from their taxes, if you went with them. So I would probably say no, I would not recommend those people. Because 40% being audited or, 0.025% just in general, okay? So that's how I would make the conclusion from our information. So we'll do some more examples together in class. These are the ones I want you to use to help you understand what's going on, and we'll talk more next time.